Hi, my name is Joe Policelli.
My name is Tom Jarvis, and we have created Biblocomplete. Ever since the invention of the Gutenberg press, we've had 500 years of books at our disposal. Books have been and still are a great technology to help people utilize information. The knowledge in books have helped us understand the rules and structures of human society and the world around us. And books have also been vital to the advancement of humans for the past 500 years.
In the past, humans have gained knowledge from understanding the abstract prose that books offered. Today, books offer us more than that. The words themselves and the sequences in which these words appear can lead us to understand natural human languages and use this to build new technologies that enable computers to understand humans in ways not previously possible. One of these technologies is autocomplete, which allows you to search faster online, to type faster on your phone, and as an internal component for speech recognition systems. With that in mind, the goal of our project was to create an autocomplete system that was based on the contents of millions of books. We wanted this system to be fast, we wanted it to be effective, we wanted it to use minimal computing resources, and we wanted it to be convenient for the end user and for developers integrating it into their own systems. Here is a demonstration of a simple application that utilizes our autocomplete system. This application allows a user to type a word or phrase and receives suggestions for upcoming words. For example, if a user types "when you wish upon," they receive a list of 10 words or phrases that may come next. You are probably not surprised to see the third result on this list, the words "a star."
This process looks really simple and easy, but there's a lot going on in the background. The first part of our architecture is the data that we pulled all of our information from. Google Books released an n-gram database. Now, n-grams are any sequence of words. In this case, we're talking about 1 gram, which is going to be 1 word, 2 grams, 2 words, all the way up to 5 grams, which is 5 words. Now, Google Books scanned all of their books, and they broke up every set of phrases into 1 to 5 grams and recorded how many times it showed up in books. We're using this data to find our solutions. This data starts out as being 3 terabytes large, which is something that isn't usable. So we had to find a way to shrink this down or to turn it into something that we could actually use.
To do this, we took the data into the data processing step, which involved a number of smaller steps within it. Done in Python, the data processing step first involved cleaning the data, removing tokens that were not words, removing unnecessary punctuation marks, and making sure that the data we were moving forward with was the type of data that would be useful for our autocomplete system. We then condensed the data, removing attributes of the data that were not necessary. After that, we sorted the data to make sure it was in the proper format for the next step of our project. All of this had to be done in a way that did not exceed the resources of the machines we were using. We could not use too much memory or too much disk space, which was an issue because we had so much data we were using.
After the data processing stage, we would take the JSON file that was outputted and we would import it into MongoDB. Now, why did we decide to use Mongo as our database? Mongo would allow us to improve our queries with our own indexing. We knew we were going to have to make a lot of queries, so this was something of importance to us to get our speed requirement. MongoDB excels with a lot of simple data. We didn't need complicated schema, and this exactly just fits the type of data we're using. And finally, Mongo scales very well with large quantities of data. And we thought that we will be using a large amount of data, so the scalability is another key aspect. The next stage is the actual selection process, where we had a Java file that pulls from MongoDB. It queries 10 times to get a total of 100 results. Now, with our weighing algorithm, we cut this down to 10 results, which then we give back to the users. This weighing algorithm is accomplished because every single possible query has a score that we gave to them in the data processing. The score is determined by whether we think that the result is valuable or not to users. Based off these scores, we have certain thresholds in place. And if scores don't meet the thresholds, we don't think that they are valuable enough and we won't use them. With this is how we get our 10 results, which we then again return to our users.
We made our data accessible via a web API so that developers could use it from whatever language or system they wanted to. Our web API uses a standard JSON format, which allows developers to not have to understand the complexity of our system to be able to use it effectively. Any developer working in any language that can make web requests and that can parse JSON can use our system due to this web API. This means the final step of our project was the clients that do use our system. And we built a web client, which you saw earlier, to test out our system and demonstrate its capabilities.
Coming to the end, our system was built with the demands of the real world in mind. Looking back at our project goals, we said we wanted to be fast, effective, minimal resources use, and convenient. We need to be fast enough so that users think that they're getting in-time results. Effectiveness means getting results that people actually want. We need a minimal resource use so we wouldn't overuse disk space and cause problems. And just like Joe was talking about, with the API, we can be convenient and be accessible to all.
Ultimately, our system is also scalable. It can be applied to other languages and specialized data sets. Even though we used Google Ngram data, you can use any sort of text data and create your own autocomplete system that works well for your specific needs.